Hello and welcome to the Linux command line video series. In this video, we will cover the ways to change file attributes of owners, groups, and permissions. Let's talk about file permissions. In the Linux world, each file will have an owner that will have certain privileges on reading, writing, or executing that file. Each file will also have permissions that allow a group of users to have privileges of reading, writing, or executing that file. And lastly, each file will have permissions for everyone else who is not the owner and not part of the group to read, write, and execute. The way to see what permissions are for a specific file, we can use the ls command with the -l option, which stands for long listing. So let's revisit the ls command and look at some of the common options. We have -a, which will list all files, including hidden files. And hidden files are files that start with a dot. And then we have ls-l, which is the long format. What this will do is now it's going to display a whole bunch of other characteristics for the file, which we'll be explaining shortly. Next, we have the ls-h for human readable. And with the -h option, you have to use it with the -l for long format. Otherwise, if you don't, it doesn't really help at all because it won't display the file sizes. So let's take a look at this folder. So as you can see, the file sizes now are human readable, right? It makes them 200K, 65 megs, 179K, 8.4 megs, and so forth. Otherwise, it actually spells it out to the exact byte, and sometimes it's a little hard to read. The next one we're going to look at is ls-R for recursive. And what this is going to do is that it is going to traverse down the tree from where you are all the way down to the subfolders. So in this case, it went into my documents folder and took a look at the folders Mickey Mouse, Mickey Mouse, and Mickey Mouse. All right, so those are some of the more common options for ls. So let's take a look at some specific examples now with file permissions. We're going to use ls-l for long format, the a for all files including hidden files, and the h for human readable. And again, remember, the options could be in any order. We could have put ALH, HAL, HLA, etc., etc. They're all the same. So we're going to take a look at these specific folders in files. So let's take a look at what we have in the long format output. So as you can see, there are groups of information on each line. Group 1 is the file type and access permission for the file. Group 2 is the number of hard links to the file. Group 3 is the file's owner. Group 4 is the file's group. Group 5 is the file size in bytes. Group 6 is the modification date, the last modification date. And then last column is the name of the file. So let's take a detailed look at group 1. We talked about group 1 being these blobs over here, which represents the file type and access permissions. So the very first character of this group represents the file type. If it is a dash, this means this is a regular file, right? Most of your files are going to be regular files. The other most common type is going to be D for directory, right? So these are the folders or directories, same thing. Next in popularity, we have L for soft links. And then we have C for a character device. B for block device. And then you may sometimes see S for sockets and P's for named pipes. So the next thing we're going to look at in group 1 is the remainder of all these. And these are called file permission bits. And they're broken into 3 sets. The first 3 is the access permissions for the owner of the file for reading, writing, and executing. The second 3 is going to be the read, write, and execute permissions for anybody in that group. And third is going to be read, write, execute permissions for everybody else who is not the owner and not in the group. So in this case, for this particular file, the owner has read permission, they have write permission, but they cannot execute. And everybody else, either in the group or everybody else, has no permissions to do anything. This next file here, for the owner can read, write, and execute. Anybody who is in the group, which in this case is the root group, has read, write, execute permissions. And everybody else who is not the owner and not in the group also has read, write, and execute permissions. For this particular file, the owner can read and write to it. If you belong to the group, in this case, the group called disk, then you could also read and write to that particular file. And lastly, if you're not the owner and you don't belong to the disk group, you have no permissions to do anything. To change the owner of a file, you can use the chown command, chown. So let's take a look at this file, etc legal. I'm going to do an ls-l, long format. And so here you see that it is owned by the account root, and the group that has access to it is also the root group. So let's go ahead and use the chown command. And we're going to basically tell it we're going to change the owner of this file to student. And you got to remember that you have to use sudo because root actually owns that file. So to verify, we just do ls-l again. And sure enough, you see that student is now the owner of that file. All right, so what if we want to change the group? Well, you can also use the chown command to change the group. So we're going to do sudo change owner. This time, let's change both the owner and the group. So we're going to specify the owner first. We're going to change it to the male owner. And then for the group, we're going to change it to the daemon group. And once again, we want up arrow twice to do the ls-l command to verify. And sure enough, we see that the owner has been changed to male and the group has been changed to daemon. And as I have said numerous times before, there are usually more than one way to do anything in Linux. So there is a specific command to change the group attribute of a file called change group. So what we can do is we can do sudo change group of legal. All right, so we're going to change the group back from daemon to root. We hit enter. Linux gives us no feedback. We're going to up arrow twice and get our own feedback. And sure enough, the group has now been changed back to root. So let me go ahead and change the owner back to root as well. Put things back to where they were. There we go. Beautiful. Now let's take a look at how to change the permissions of a file. And to do that, right, we're going to be changing these bits over here. We are going to be using the chmod, chmod command. The chmod command changes the file's mode bits so that when you use the ls-l, you can see what they are. And there are two ways of how to change these mode bits. One of them is using a symbolic representation, and then the other one is using an octal number that represents the bit patterns. Different people have different preferences. We're going to go through both so you can make your own decisions. All right, so like I said, the first way is using a symbolic representation. And what this means is that because we can change the user permissions, the group permissions, And then the other permissions, you can use the letters U for user, G for group, and O for other when you want to change these bits. Or you can say A for all of these bits. And then what you're going to do is you're going to pick the operation that you want to do. Do you want to add permissions? Do you want to subtract permissions? Or do you want to set permissions to a certain thing? And lastly, you're going to give it a series of letters just like these, R, W, and X, to represent the bits that you want to set. So let's go ahead and do an example again. So in this example for this file, let's say we want to allow the user to also execute this file. So let's say this file is a program, and right now, because the execute bit is not set, you cannot execute this file. So let's go ahead and set the execute bit. And the way to do that is we're going to do chmod of user. We're going to add the execute bit. And once again, we're going to do the sudo beforehand just to make sure. Okay, once we execute the command, let's go ahead and up arrow twice to get a confirmation. And sure enough, we see that the one bit that has changed is for the user's permissions. We have added the execute bit. All right, so here we did user, and we're going to add the execute bit. So let's do another example. We can do sudo chmod. Let's say we want to go other and minus the read, right? Because right now everybody can read this file. Let's say I want to make it so that only the owner can read it, or else if you belong to the group, the root group, then you can read it. So let's go ahead and do that. All right, so others minus R, removing the read permissions. And sure enough, we see that the read bit is unset. So if you're not the root user, you're not part of the root group, you're not able to read this file. So let's try that out. And sure enough, there you go. You get the permission denied. You can combine multiple settings in the same command if you separate them with a comma. So let's go ahead and take a look at the etc legal file again. So right now it's set to read, write, execute for the user, read only for the group, and nothing for everybody else. So what we're going to do is chmod user subtract the right bit, group, we're going to add the right bit, and for other, we are going to make it write and execute. So we have all those on the same line. So let's go and double check. And sure enough, we see that the right bit has been removed for the user, the owner. The right bit has been set for the group. And the others attributes is write and execute, just as we had set it up here. And so that's how you use chmod with the symbolic representation. The second method of using chmod is the octal representation. What the command will look like is something like this. So we're going to say chmod, and then we're going to give it a couple of octal numbers, and then name of a file. The way we derive those three octal numbers is as such. First, we have to decide what permissions we want each set to possess. So the user, the group, and the other. So for example, if we want to grant read, write, and execute permissions to the user, and we want to grant read and write permissions to the group, and we want to grant only read permissions to others. This is represented here in this chart. Now we treat each granted permission as a binary bit. So the RWX becomes a 1, 1, 1. The RMW is a 1, 1, 0. And then the R is just the 1, 0, 0. Last up is that we convert this binary set of numbers to octal. So a 1, 1, 1 is basically 7. A 1, 1, 0 in binary converts to 6 in octal. And a 1, 0, 0 converts to a 4 in octal. So let's take a look at an example. So we're going to take a look at the etc legal file again. Right now we have these particular permission bits set. And like we said before, we have determined that we actually want the permission bits to be a 7, a 6, and a 4. So we can do sudo chmod 764 of etc legal. And then let's take a look at the verification. So sure enough, we have read, write, and execute, right, which is a 7. We have read and write, which is a 6. And then read only, which is a 4. So let's do that again by restoring it back to the original. And the original, if you don't remember, is basically a 644, which gives read and write permission to the user, and then read only permissions to other and the group. So once we do that, we're going to do ls-l to verify again. So sure enough, we have read and write for the owner, read only for both the other and the group. So that's how you use octal representation with chmod. All right, so that brings us to the end of this video, where we looked at managing permissions and setting owners and groups for files and directories. We took a more in-depth look at the ls command with the -l option and looked at the commands chmod, chown, and change group. Hope you enjoyed it, and if so, click on the thumbs up icon to like this video. Please hit the subscribe button to get notified when the next video comes out. Also, please leave me messages in the comment section below so I know what you liked and didn't like, or what you may want to see in future videos. See you next time.